This video goes along with the first section of reading in chapter 16. And we will move from talking about probabilities to talking more about random variables. Now, the ideas are connected in that you can think about rolling a dice as a random variable. That value could be 1, 2, 3, 4, 5, or 6. Okay, and any event or an outcome can be thought about as a random variable. Now, random variables could be discrete or they could be continuous. Now, discrete is where they're separate individual numbers, like rolling a dice could be 1, 2, 3, 4, 5, or 6. You can't roll a dice and get 3.5 or 2 1/3. Okay? Drawing a card, again, there's only certain numbers that can be drawn. The number of Facebook posts have to be a whole number. You can't have, 2.5 Facebook posts. Okay? Continuous random variables are where it could be anything within a certain interval. So the time length on Facebook, that does make sense to have 2 1/4 hours. Does make sense. Okay, number of weight loss during wrestling season could be continuous because it could be any number within an interval. Okay, the amount of money you spend on lunch again could be continuous. Okay, we will focus on this in this first section on discrete random variables, and the next section of reading is on continuous random variables. Okay, the first way to talk about discrete random variables is in a probability model, and the book talks about, I think, in life insurance policies and the payout in death or disability or neither. Okay, and those are laid up in this chart, and over here are the probabilities where each of these events could happen. Okay, and this probability model is very powerful for us and helps us to analyze the situation a bit more. Okay, the first question to ask is about the center. Okay, and what do we expect to pay out if given these probabilities, and the amount that you would expect conveniently turns out to be the amount times the probability of that amount, plus the amount times the probability of that amount, plus the amount times the probability of that amount. And that if you calculate that, that'll give you the expected value, how much you would expect to pay out. Okay, and these types of calculations are done all the time on insurance costs, whether it's health insurance or life insurance. This type of math is done very frequently in business, and it's a very useful tool. Okay. Now, if you want to look at it, using a formal equation, using the sigma notation, it is the value times the probability of that value, and you add them all up. Okay. Here's an example of a card game. Okay, where here are the payouts or the amount of points or amount of money you get, and the probabilities of getting each of those, and you find the expected value by multiplying the number times the probability that you get that number, and you add them all up and you get the expected outcome. Okay, next we'll turn to the spread, okay, which is very similar to how we found spread before. Again, we will look at deviations from the mean or deviations from the expected value. We will square those, okay, multiply those squared deviations times the probability of getting those deviations. Okay, that gives you the variance. Okay, and again, to find the standard deviation, you take the square root of the variance. Okay, we will never have to calculate the standard deviation or the variance of these by hand, but it's really helpful for you to have a gut feeling about how these are calculated and what that means for the standard deviation to be big or small. Okay, here's the same example, but now calculating for the standard deviation. You would take the differences from the expected value, you'd square those and multiply by the probability you get that value. Okay, you add those all up, then take the square root at the very end to find the standard deviation. Okay, on your calculator, this TI tip walks you through on your calculator how to fill those out. You'll put the payouts or the points or whatever in list 1, the probabilities that correspond with those in list 2, and you'll do a tricky thing of 1 var stats L1 comma L2, and then hit enter. and that'll give you, it'll run the statistics the way you think they would. Okay, um, let's transition a little bit from discrete random variables to more about those, but how multiple variables are related to each other. Okay, first about shifting and rescaling these random variables. Okay, just like you would guess from before, if you add a constant times all the payouts or all the values, you will increase your expected value by that same amount. Okay, and similarly, if you add a constant, you would not change the variation or the standard deviation. Okay, and again, just like before, if you multiply all the payouts by a certain number, that would affect the expected value multiplied by that number as well, and the standard deviation would be multiplied by that number as well, and the variation by that number squared. Okay. Um, Now, if we had two variables and we're adding them together, okay, the expected values will add together. Like if you're rolling two dice, you would take the amount, the number you expect to roll on one dice and add it to the second dice, and that would give you, an expected um, outcome from two dice. Okay. Now that follows our intuition. The standard deviation, on the other hand, does not follow your intuition. You don't add the standard deviations. Okay. But it is true that you add the variances. Okay, the variances will add. So if you take the variation from one variable and add it to the variance, sorry, variance, not variation, variance on the other variable, those will add together, okay, which is different from doubling one variable. The book makes a big point about this fact, okay? So in general, the expected values will add for variables. They will also add for variances. Okay, and that's true whether or not you're adding or subtracting. Okay, now the way you find the standard deviation is by using what I call the Pythagorean theorem of statistics. Okay, the variances add, and the variances are the standard deviation squared. So to find the standard deviation, you'll take the square root of the standard deviations squared. This reminds me very much of the Pythagorean theorem. Okay, and that really ends it for our discussion about discrete random variables, the center, which we call the expected value, the spread, how to shift and rescale them, and also how to deal with multiple variables, how they add or subtract.